This is where you start out in gymnastics. And then you get a little bit better. And then really good. So what does physics have to do with gymnastics? Take this back handspring for an example. The force of the floor on the gymnast and the force of the gymnast on the floor are the same. In this back tuck, the force comes from her legs and the raising of her arms. In this front tuck, Victoria throws her upper body forwards and applies the horizontal force to her feet. This torque helps her flip and twist. Watch how, when you decrease the center of mass, a tuck rotates quicker than a layout position does. I'm so sick of this tombstone mentality. There's an afterlife and it'll set you free, but I'm not. When your muscles are tight on a turn, you can spin quickly like this double turn, and you're directly over your center of mass. Try doing that 3 times. Kinetic energy equals 1/2 mv squared. This means when you accelerate your run, you have more kinetic energy. In this 2.5 twist, Victoria possesses a lot of angular momentum through her left and right axis. Now all she has to do is look with her head and put her arms in the direction she wants to twist. Take a look at Victoria's arms and head when she twists. Also check out how she spins slower in the layout than she does in her tuck. Little Kaylee here is showing how less mass requires less energy to complete her skills. Another theory is the impulse momentum theory. It is force times time equals mass times velocity. When you bend your knees, you increase the time to land and puts less force on you. If you don't absorb the landing by bending your knees, then you'll fall off. Bending your knees also prevents injuries and is better on your joints. The balance beam is a 4-inch piece of wood with padding. It's really hard to keep your balance, so when you feel yourself starting to fall, bend your knees, which will drop your center of gravity to regain your balance. Another event is the vault. The key to vaulting is accelerating your run, punching the board hard, and blocking. If you block correctly, your shoulders should act like a spring, which increases your potential energy. This vault is called the Sukahara. The angle that you hit the vault affects the projectile distance, height, and rotation. The angle of incidence on the vault is going to equal the angle of reflection. To reach your maximum height, you want to block as fast as you can. This is my favorite event, the bars. The bars are a great representation of momentum. To increase your momentum, you want to apply an unbalanced force by kicking your legs or changing the position of your hips or arms. Another unique characteristic about the bars is that they give or bend so that we can keep our momentum going and we'll have less force on our hands. Newton's first law states that I will remain in motion until the floor, which is the outside force, stops me. The giant is definitely a good representation of centripetal force. Victoria keeps moving in circles and the swing keeps her in motion. If you look at Victoria's hands, she's wearing grips, which helps reduce the friction on her hands. We also put chalk on them so we don't slip. This dismount is called a toe front. Victoria is using the pit because gravity sometimes makes us do crazy things like land on our head. This is a toe shoot. You have to hit a handstand at the end, otherwise you're going to fall. If your center of gravity isn't directly over your hands, then you're going to go the wrong direction, like this. The rope swing is a favorite for little kids. Notice when she swings on the rope, she can't go any higher than when she started, unless she's pushed, and then she goes higher in the other direction. Now,
camera. And Andy holding the camera.
These physics inspirers, or coaches, are Kevin and Tara. The only thing left to see are the physics errors.
Me and Ice Pack equal good friends.
Leave gymnastics up to the ladies. The boys aren't as tough as you think.